This is Radhika. I am going to give a video lecture on switchgear and protection. In this, we are going to discuss about the protection and transmission lines and feeders. So this is the topic we are going to discuss today. Under this, we are going to discuss about the understand transmission line feeders protection. Actually, how we can use the transmission lines and feeder protection. So today in this main object is the protective systems applied to transmission lines and feeders. So just actually what is the protection of feeders and transmission lines? In an electrical power system, the transmission lines and feeders are implement elements which needs to be protected against the various faults that occur on them. The schemes employed for protection of transformers, alternators and bus bars can also used for protection of transmission. In the schemes employed for protection of transformers, alternators and bus bars can also used for protection of transmission lines and feeders with slight modification. The modifications are required to cope with the protection problem arising out of the greater length of lines. Further, differential protection can be used, but it becomes too expensive for longer lines due to greater length of pellet wires required. However, less extensive methods are available which provides effective protection to the transmission lines and feeders. So, there are several methods of protection of transmission lines. The first group of non-unit type of protection is time graded over current protection, current graded over current protection, distance protection. So, these are the first group of non-unit type of protection. Such non-unit type protections do not have pilots. Fuses are used in distribution systems where relays and circuit breakers are not necessary. And also, the protection of feeders and transmission lines. The other group of protection of line is unit type protection, such as pilot wire different protection, carrier current protection based on phase comparison. The aim of feeder production is to ensure the continuity of supply. There are a number of methods for protection of feeders against various types of faults that are overcurrent protection, earth leakage protection are important. And also time and current graded protection is used where a time lag we can permit it. Distance relaying is employed where time lag cannot be permitted. Unity protection provides fast selective clearing. So here in busbar protection, the protection of bus bars is very important since they form a vital part of the supply system. What is the necessity of bus bars? The bus bar protection is needed for the few reasons that are in case of fault on a bus bar, the fault current and power may be very large and cause serious damage to the system. Fault on the bus bars may affect continuity of power supply and cause discontinuation of power to a large portion of the system. The stability of the system is affected by fault in bus zone. In case of a large power system, protection of bus bar section is necessary so that faulty sections are isolated before the fault spreads over the whole system. So the necessary so that the faulty sections are isolated before the fault spreads over the whole system. For the purpose of protection, the bus bar zone includes the bus bars, the circuit breakers and isolating switches. When a fault occurs on a particular section of a bus bar or circuit, equipments connected to that section must be tripped out to isolate the section completely. The desirable features are: it should be select and isolate only the faulty section. It should clear all bus bar faults as quickly as possible. It should avoid the use of multi-tripping relays, and no relay should control more than one circuit. It should clear all the circuit connected to a faulty bus bar section. And the causes for bus bar faults: the bus bar fault are generally single line to ground faults. The following are the few causes: means it is the failure of support insulators resulting in earth faults, flash over across support insulator during over voltages, heavily polluted insulator causing flashover, failure of connected equipment, and the last is the due to earthquake, mechanical damages, etc. So here in this, the protection of feeders and transmission lines, the pellet wire protection based on differential circulating current principle are used for short lines. Carrier current protection is used for long lines. It provides a fast relaying. Auto re-enclosure schemes are provided in the protection of distribution lines and transmission lines. This improves system stability. So here the types of schemes for bus bar protection. There are two main schemes of bus bar protection, namely differential protection and frame leakage protection. The differential protection is based on simple circulating current principle that during normal load condition or external fault condition, the sum of currents entering a bus equals the sum of those leaving. A simple differential protection of a bus section: the bus bar is fed by a generators and supplies load to three lines. The CTs are connected in each circuit connected to the bus bar. The secondaries of these CTs are connected in parallel. The protective relay is connected across this parallel connection. All CTs must be of the same ratio in the scheme regardless of capacities of various circuits. If a fault occurs within the protected zone, the current entering the bus will no longer be equal to those leaving it. The difference of these currents will flow through the relay and cause the opening of the generator breakers and each of the line circuit breakers. In frame leakage protection, if it possible to design a station so that The faults which develops are mostly earth faults. By providing earthed metal barrier surrounding each conductor in the bus structure. With this arrangement, every fault that might occur must involve a connected connection between a conductor and an earthed metal part. Frame leakage protection is normally applied to small sized metal clad switchgear units. The switchgear frame is lightly insulated from its adjacent earthed structures still work for this scheme of protection. In case of a station having an incoming transformer and two outgoing feeders, as will be seen from this figure, the switchgear framework is connected to the station main earth through the primary of CT. The secondary of CT is connected to a sensitive framework leakage relay. In the event of earth fault currents flowing in the switchgear framework, this relay will operate. The check relay is an earth fault relay energized from a current transformer mounted in the incoming transformer neutral earth connection. The contacts of check relay and frame earth leakage relay are in series so that the independent relays must operate before the trip circuit is completed. And the bus bars arranging. The aim of any particular arrangement of bus bars is to achieve sufficient flexibility of operation, sufficient reliability, and minimum cost. We have few typical bus bar arrangements, that are single bus bar and duplicate bus bar. In single bus bar, the layout is meant only for small station. The basic schemes, so uh, the generator, circuit breakers and switch means isolator respectively, while the step up transformer, it presents present day practice, however, does not favor such a large number of circuit breakers. Circuit breakers on low voltage side and of transformers may therefore be omitted in some cases. The preferred practice on unit system where one generator and one transformer are connected as a unit to HV bus bars is to do away with two voltage switchgear altogether and have only one set of high voltage switchgear. With more generators and outgoing line connected to the bus bars, is become necessary to sectionalize a layout so that the fault on one section does not cause a complete shutdown. This can be done by a circuit breaker, is called bus coupler, and isolating switches. The two bus bar sections so tied up. And also we have the duplicate bus bar. In duplicate bus bar, the plant is split into two entirely separate systems which can be worked at different voltages if desired. If both LV and HV bus bars are high voltage bus bars, alone may be duplicated. This is the most flexible layout and is meant for large generating and or transforming stations. In figure, this type of layout in the case of a large generating station having two generators and two outgoing lines connected through step-up transformers. The use of a bus bar coupler BC converts the duplicate bus bars into a ring system which has greater flexibility. So, this is the basic concept about protection of transmission lines and feeders. Now, we will watch one YouTube video regarding protection of transmission lines and feeders.
Production of lines or feeders. Let us clear this thing to everyone that any electrical equipment which has been placed inside some storage devices under roof or any other shed, so they are most protected. It means any electrical equipment which is exposed to the atmosphere, so they have a most security problem related to any fault may happen to this electrical equipment. So it is very much necessary that we must have a special security for those type of equipments. For example, if we have a generator, transformer, motor, so these equipments are placed inside some casing, and under that casing the electrical accessories are mounted, so they are more safe. But if we consider the transmission or distribution lines, they are very long in length and they are running in open atmosphere, so they are always open to the atmosphere. There is no any covering is provided in these lines, so anytime any fault may happen to these lines which are running for the long span length. So it is very much essential now that these transmission and distribution lines must be protected with a very special purpose protection system in compared to the transformers, alternators, generators. So same thing is defined here that as the length of electrical power transmission line is generally long enough and it runs through open atmosphere, the probability of occurring fault in electrical power transmission line is much higher than that of electrical power transformers and alternators. That is why a transmission line requires much more protective schemes than a transformer and an alternator. So the same thing we have discussed that compared to the alternator, transformer or generators, the distribution and transmission line, they must be given a more security compared to these equipments. So let us say the production of line should have some special features. If you are talking about the transmission lines, it means production of lines should have some special features such as during fault, the only circuit breaker closest to the fault point should be tripped. It is but natural that the circuit breaker which is placed or very near to the fault, that must be tripped first. If the circuit breaker closest to the faulty point fails to trip, the circuit breaker just next to the circuit breaker will trip as a backup. As we have studied in the primary and backup protection, that there is a primary protection and then there is a secondary protection or backup protection. So if there is any fault, then first primary protection will come into action, and if by any means the primary protection fails, then the secondary protection will come into the picture and that will immediately protect the system. And third point is the operating time of relay associated with production of the line should be as minimum as possible in order to prevent unnecessary tripping of circuit breakers associated with other healthy part of the system. So it means we should have a minimum time operating for a production system or for any switchgear device so that during any fault condition with a minimum time delay the production system should operate. These above mentioned requirements cause production of transmission line much different from production of transformers and other equipments of the power systems. And because of this, the production of the lines are taken much care compared to the transformers or the generators or other equipments of the power system. So main three methods of the transmission line production are classified. First is the time graded overcurrent production. Second is the differential production. And third is the distance production. The last two, that is the differential production and distance production, already we have studied in previous classes. What is time graded overcurrent production? It is nothing but certain time priority is given to the overcurrent production. That's why it is called the time graded overcurrent production. So we'll discuss in next slide what is time graded overcurrent production. Now time graded overproduction is defined as that this may also be referred simply as overcurrent production of electrical power transmission line. Let us discuss different schemes of time graded overcurrent production. Now we will discuss what are the different schemes of time graded overcurrent production system. So first is the production of radial feeders. We should first understand that what are the radial feeders. It means radial feeders. In radial feeders, the power flows in one direction only, which is from source to load. As we know that around us there are various distribution lines or transmission lines where from substation or from the main station power flows towards the load, so that is in one direction only. So these are called the radial feeders. This type of feeders can easily be protected by using either definite time relays or inverse time relays. So definite time relays means these relays operate at a definite time. And what is inverse time relays? They operate inversely proportional to time. Their operating characteristics as a inversely proportional to time. That's why they are called the inverse time relays. So line protection by definite time relay. If you want to protect the distribution lines or transmission lines by definite time relay, so what is this scheme? We will discuss here. That this protection scheme is very simple. Here total line is divided into different sections and each section is provided with definite time relay. The relay nearest to the end of the line has a minimum time setting, while time setting of other relays successively increased towards the source. So what is written here, same thing I want to explain here with this diagram. Now let us say this is the length of the transmission line or distribution line, and that has been measured in terms of the distance. That's why here it is a distance measurement has been shown here. Now this is the operating time. Let us say they are the different circuit breakers which are connected in a span of the transmission line, certain span length of the transmission line. Let us say this is A circuit breaker, this is the B CB1 circuit breaker, and at the place C CB2 circuit breaker, and at the place D CB3 circuit breaker is mounted. So what we see here, for this circuit breaker 3, the time setting is given 0.5 seconds, and for the circuit breaker CB2, the time second is given 1 second. Time setting is given 1 setting. That is the relay at which it operates, that time is 1 second. Similarly, for the CB1, time setting is given 1.5 seconds. That means that after 1.5 second, relay of circuit breaker CB1 will operate if there is any fault in the distribution or transmission line. Similarly, there is a CB which is placed at a point, so that is the nearest to the source. We can say this CB is very nearest to the source, and for this relay, time of operation is given as a 2 seconds. It means after 2 seconds, the relay of this circuit breaker will operate. So what we see that if we move towards the source side successively, for each relay the time setting is increased. That is, for this relay 0.5 second, for this relay 1 second, 1.5 second, and 2 seconds. So as the length of span increases and we are going away from the source, the time second setting is decreases successively. Now let us define this, how this system will operate. At point D, the circuit breaker CB3 is installed with definite time of relay operation 0.5 second. Successively at point C, another circuit breaker CB2 is installed with definite time relay of operation 1 second. Next circuit breaker CB1 is installed at the point B, which is nearest to the point A. At point B, the relay is set at time of operation of 1.5 second. So this is same thing is written what I have described you in the previous slide. Now let us see in the next case. Now assume a fault occurs at point F. At point F means, let us go back and see, this is the point F. So now we suppose that a fault occurs at this point F. Then what will happen? Let us see what is saying. Now assume a fault occurs at point F. Due to this fault, the faulty current flow through all the current transformers or CTs connected in the line. Certainly, since these all CBs are connected in series with the line and fault point is as farthest distance from the source, so the source current will flow through all circuit breakers because they all are coming in series. But as the time of operation of relay at point D is minimum, the CB3 associated with this relay will trip first to isolate the faulty zone of the rest part of the line. In case due to any reason CB3 fails to trip, then next higher timed relay will operate to initiate the associated CB to trip. In this case, CB2 will trip, and if CB2 also fails to trip, then circuit breaker, that is CB1, will trip to isolate the major portion of the line. So what is written here that I want to explain with this figure. Now let us say the fault is here at this point. So as soon as the fault occurs at this point, at very first stage, the relay or the circuit breaker which is nearest to this fault point will operate first. And now here this is a CB3. So time setting for CB3 is given 0.5 second. It means first this CB3 will operate. That will be called as a primary protection. And if this CB3 fails to operate by any means, then next to the CB2 is placed, and for CB2 the time setting is given as 1 second. So this CB2 will operate. Now by any means, if CB2 also fails to trip or fails to operate, then next to CB2, CB1 is placed in series with the transmission line. And for this CB1, the time of operation is given as a 1.5 second. So what we can see from this system, that if CB3 immediately operates, it will isolate the faulty system with the minimum time delay, and also a small length of the production will be isolated, and rest healthy system will be carry on supplying the power. But if this is also not operating and CB2 is also fails to operate, then CB1 will operate. But if CB1 is operating, then what we are seeing that it takes a time of operation of 1.5 seconds. First of all, up to 1.5 seconds, this power from source will be carry on feeding to the fault point. That is not desirable. First thing. And second thing, when CB1 will operate, it means most part of the length of this line will be disconnected from the source. That is also not desirable for the efficient production system. That is what is written here in this part. So here we have defined what are the advantage of definite timeline production or what are the disadvantage of definite timeline production system. Because we have provided relays, these are called the definite time relays, and we are protecting certain length of the transmission line. So what are the advantages and disadvantages of this definite time production system? Main advantage of this scheme is simplicity, and second major advantage is that during fault, only nearest CB toward the source from fault point will operate to isolate the specific position of the line. This is the advantage. And what is the disadvantage of definite time line production? That if the number of sections in the line is quite large, the time setting of relay nearest to the source would be very long. So during any fault near to the source will take much time to be isolated. This may cause a severe destructive effect on the system. So same thing, let us go back to this diagram, that he wants to say that if the span of length of this transmission line is very long, so certainly if the length of the transmission line is very long, then we have to divide this line into so many length of the sections. So we have to provide so many circuit breakers in the long length of the transmission line, and accordingly we have to divide the time setting for each circuit breaker. So if fault happens at the extreme end, and anyways if the circuit breaker fails to operate, so as long as we are reaching toward the source side, the time duration which be much more compared to the smaller span length of the transmission line. So this is not desirable for protection of the transmission system. Same thing has been told here. So this is what about the protection of transmission line or.
Now we watched the YouTube video regarding protection of transmission lines and feeders. So this is the today's class, and today we discussed about the different protection systems used for the protection of transmission lines and feeders depending upon the necessity of time lag, fast redelaying, system stability. And here we have the few quiz questions and few frequently asked questions, and this is the class about protection of transmission lines and feeders. Thank you.